I submitted it for publication, and now I'm waiting to hear back.
I
was
like,
cool. 3 weeks ago.
Why would you do that?
Expecting to wait another 3 weeks to actually hear it back, and then I'll have to do a bunch more work to address feedback.
Wait, it's a hurry up and wait sort of situation. So I've been doing other projects in the meantime.
Stop being a little shit.
But I don't know what I'm working on. In the meantime.
Howdy, everybody. May I get your attention?
What channel you
Frontiers and Computational.
Thank you, everybody, for joining our monthly lecture meetup. Bit of housekeeping first. Please stay off the stage. If you have any conversations, please move into the back areas. As your sound will project, please keep your conversations out of the lecture area. Thank you very much. Now, for those who are joining on stream, we are live now. This is our lecture portion for our monthly meetup for DegenTech. DegenTech is a community of professional furries working in the STEM fields, STEM being science, technology, engineering, mathematics, and medical. And DegenTech, we are a virtual reality group. We hang out on virtual reality, which is where we are right now in VR chat, and we organize on Discord. So if you are finding out about this on YouTube, please check us out. We have also a whole compendium on our YouTube of previous lectures. So please check out our other previous lectures to learn about a whole bunch of cool technical topics. So shortly here, we'll be having Apotek come up to the stage to give their talk. But I have a bit of a surprise announcement first. And I want to thank Apotek for allowing me to give it before his lecture. So recently, I've stepped down as admin for DegenTech. Formal ownership has been transferred over to Apotek. DT over there is the other co-admin. I am currently taking on the role as an external community liaison. So if you are having another community that is trying to coordinate with DegenTech and have been communicating with me, please continue to do so. There will be no changes there. There won't be any real changes internally. Just I will not be involved in coordinating events and unilaterally making changes to the group as much as I was in the past. All right. So I want to be clear. I'm not leaving. All right. I'm still sticking around. What's happening is that things are going well. We have regular events now. We have 3-4 events a week. We have a thriving community. We just crossed our 900 member threshold. We have a really robust staff. We have a lot of volunteers, and things are expanding at a very good rate. This is the time to do it. What I'm doing is establishing succession. I'm not leaving. One of the things that I've always wanted is for the community to take ownership in what happens to the community. They need to have ownership of the community as well. And this is your community. You are the community. You are the people who make this and make the events actually worth something and make this group worth something. And the power is in your hands. All right. So please help out, enjoy, and just have a good time. I love hanging out with you guys. I'm not going anywhere. And I will be making plenty of time to answer any questions after this lecture. All right. So for now, please, I would love to introduce my good friend, physicist, entrepreneur, and almost doctored everything but name. Why isn't the review approved yet? Apotek, and they'll be giving a lecture on how to build a Protogen head. So please welcome to the stage.
Hi. Okay, thank you. I think we don't have to hold the microphone, right? Clap. Okay, thank you. Okay, great. Thank you, everyone. Thank you, Vitex, for the introduction. And yeah, we did change ownership. It's not going to change a lot about the how the group is presented to outside. But as Vitex said, it's very important for us to keep like a succession, so the group keeps growing and being a good group, even if it needs to transcend a single person, basically. And I think that. Yeah, it's gonna go great. We're gonna keep going and growing and being and running good events and everything is gonna be great. Yes. So let's start with the lecture. Yes. So today I'm gonna talk to you about some project that I did past year. Most of you already know about. It was a bit crazy, to be honest, because of the time and also because of my background. My background is not typical in the. I'm gonna rotate because of the tracking. It's not typical in the fursuit manufacturing community. So the fursuit ended up just basically a reflection of myself. And I think that's extremely important when you make a fursuit to reflect yourself. So it ended up very nice. But we're going to talk about this because it was an adventure and it was extremely interesting. I learned a lot, and I want to share to you, to all of you, what I learned, how to do this. I learned a lot of experience, and I want to transfer to other people to make their life a bit simpler. If you want to build a Protogen here, so let's start. If I can find my controller. So this is the Protogen here that I'm talking about. I built this thing in 1.5 months past year. This is me being a goofy in Tokyo after doing that. So I'm going to talk to you about the story of this thing. Why is it interesting? I made this thing in a record time, completely record time. I went from not having zero experience about fursuit making to having the whole thing in 1 month. Why did I do that? I'm going to talk about why in a second. We're going to go through first, like choosing materials, choosing providers, designing the whole thing, planning the build, assembling the whole thing, how to make a visor, how to not make a visor, and then a couple of things I learned during the road and improvements over the design that I did after the thing was built. So, am I crazy? A bit, to be honest, because this was way more work than I thought it was going to be. But yeah, I put that constraint with time that made me work during the night like a lot. Okay, so why the time constraint? It was June 2025, and I wanted to have a pursuit for your reference. Honestly, I could have started earlier, but I didn't. So I contacted a couple of fursuit makers. You know, I checked Twitter, I checked Instagram, so on and so forth. That did not work at all. I didn't even get answers, and I had a lot of issues with that. I started checking the prices of Protogen as well, and it was like quite expensive, honestly. And I was thinking, wait a second, I have a lot of engineering experience, and honestly, the things I'm seeing, like I could do, or I have ways to improve what I'm seeing here. I don't want to commission, so I'm gonna build it myself. So also I was checking like parties and such things I do a lot in Furcons here, raving with Fox in front here in a lot of cons all over the world, and it's like, yeah, this is really fun. You know, you can do a lot of audio link and audio stuff with microprocessors and such. So yeah, let's build a Protogen, even if it's not what I usually use in VR. I thought it was better IRL. It presented like a better image. It just worked better in parties. I was thinking about that, so I went with a Protogen. It can't be that hard, right? We all know it's not that hard. I'm sure I'm just gonna buy a bunch of fur and stick it to a freaking mold and it's gonna work, right? Okay. Let me say a couple of things about me, about why my background is not exactly the right one of the typical one for fursuit making. Like, just to be clear, because of the title, I'm not an engineer. I'm an applied physicist. My degree is in applied physics, and I'm an entrepreneur, meaning that I found companies, and I founded my own company, which is running. And this is technological company. Basically, I manufacture microfabrication equipment, and I export all over the world. So I have a lot of mechatronics experience in very high precision manufacturing, even overseas, and then manufacturing in factories, and then shipping all over the world and assembling these things, and then shipping finished stuff to customers and such. That means I also have access to a good shop. But this is very different to the skill set that you usually use for fursuit making. I've never worked with fabrics. I have no idea how to sew. I have never ever worked with fox fur, you know, the usual material people use. I don't know how to do thermoforming. I never did. We're talking about the visor that we're going to talk later. And these last two items I list here are very, very unique of this specific industry. I pre-plan everything when I do a technological build, at least as much as I can, mostly based on previous experience. But that means I made proper 3D models, schematics, blueprints for manufacturing. This is something like no one does in this industry. Everyone just eyeballs of stuff, and it was just really going against my intuition about how to build this. And I don't like to use hot glue, which a lot of people, everyone uses hot glue for building everything, and like craft and arts kind of project. And my skill set is not really aligned with that. But anyways, these are the things that I crashed with when I started this project. So let's go a bit about what I did for the planning, because of course I planned it, because of course I planned stuff. Anyway, let's start. I did some research. Then the idea was to do like the design of this around what I researched, then constructing it, basically constructing all the mechanical, all the fur, the electronics around it, and then making the visor, which was in parallel of all of this, then thinking about power management at the end, and then what to do with the firmware. Basically, this is the plan for building the thing. So what did we do? What did we do and didn't? Okay, research. We start looking around online. Let's Google Protogen head. Okay, can we find Protogen head blueprints? Yes, we can find a lot. Immediately find Coelacan repository in Gumroad. Okay, they provide actually like 5 different Protogen designs that are really, really good. Check them out. They don't provide the step files. Step files are not mesh files, but they have curvature. They are important when you want to design over them. It's like, imagine in code, it's equivalent to have like a compiled code versus the not compiled code that you can actually edit. So the step files are paid, which is not a problem. You just have to be aware that they're paid. But what I found immediately is this, which is a board adapter for a different Protogen design, which looked kind of simple-ish in the simple side of the Protogens. Which, to be honest, being my first build, I wanted to do a simple-ish design. And I checked what was this design. Okay, it's a design by Boxcat, which I checked it, and it was really cool. It was really, really well made. I liked it. And they provide a step file for free. And they have an inner mask where your face basically sits towards. So the internal points of pressure, I thought, okay, this is more comfortable to wear. Okay, I'm gonna go with this one. And I can also edit this quite easily, I think, to add my stuff. And this board adapter connects to this display, which I thought, okay, this display is really cool. For starters, it's not rectangular. That's cool. Okay, I want to use this display. How do I use this display? Okay. Okay, cool. I'm literally providing all the blueprints for manufacturing this display. Okay, because you're not gonna buy this display. Apparently, they sell it if you want, but they also provide the Gerber files, and you can send these Gerber files online to a PCB assembler, and they're gonna make it for you. And this is the firmware. It's a full firmware called ProtoTracer, which is a firmware for Protogens. And it runs in a Teensy 4.1 and completely runs this display that we just researched. So, okay, we have a plan now. We're going to use Boxcat head, this display, this adapter, and this firmware. Okay, lovely. Let's start with the full design. Okay. Let's go with the mechanical design. Let's download the previews. Okay. Why is it going back? Stay. Good boy. And okay, we have the Boxcat design we downloaded, top left. That's all the files that we downloaded, the step files. We're gonna import them into SolidWorks, and then we're gonna work around it and add our customizations, aesthetic stuff. I wanted to add some light pipes on the side ear thingies, and put some custom LED boards behind them. Why is it automatically playing? I don't know. I don't want you to play. Panel adapters. The panel adapters we have. And this is an Ardo Dragon. Literally VRChat model. I literally took the ears out of them, along with the horns. And I managed to get them into SolidWorks after 5 hours of struggling with that, which is kind of extremely difficult. And then I ended up with this. Basically, I managed to integrate everything in a singular design, and added all the mechanical connections to connect the ears and the horns with screws. This was non-trivial. This took like a good week of work on top of the Boxcat design. But yeah, okay, this looks really cool. Okay, I'm gonna build this. This is what I want to build. Great. Electronics. Okay. We downloaded the four-layer Gerber files and pick and place files from the Koala repository literally on Gumroad. Okay, great. We have all the files. We can send that to manufacturers. You have to like the manufacturer's gonna panelize it and everything. We have all the pick and place design. We have to populate it one side for one side and the other side for the other side. I designed my own boards for my accessories, you know, the ear accessories for the LEDs, and I designed it in a way that both are mirrored, so you can run both displays with the same signals without having to generate two different signals for both. Because the Koala panels, you have to send different signal for one than for the other because the LEDs are connected in a different order for both sides. In my case, they are literally mirrored, physically mirrored, so you can share the control lines. And then I designed a nice controller board that apparently no one does. For some reason, people just improvise this part. Like they grab a teensy and they start wiring things and using a lot of hot glue that I hate, as I said before. So yeah, I designed a controller board with a teensy 4.1, a USB-C connector, a button, an external button to control the firmware, the prototracer, and all the LED outputs. You know, this board, by the way, if you guys want to know, like sending this board to manufacturer is $2 for 5 units, okay? The bare board with no components. So it's really worth it to make a PCB and not spending 3 hours wiring everything manually. Just for the ones who don't have experience and are into like first building. Okay, let's see how we manufacture all of this. We already planned everything. Okay, we have all the files, all the design files for what we want to do. Okay, let's do it. Okay, how do we manufacture the structural parts? I decided to 3D print everything in SLS nylon. SLS is this 3D printing technique that you put a layer of powder, nylon powder, and you hit it with a laser to sinter it. Okay, this is not regular 3D printing. This is industrial level 3D printing, but JLC in China, they do it for very low cost, and you can totally just submit the files, and you get them delivered to your house in like a week. Okay, so you do that. I did that. I loaded all the SLS parts in nylon, sent them to JLC. I added the light pipes and all the transparent parts. That's a 3D printing in SLA, which is a transparent resin. Okay, that you just print with ultraviolet light. Basically, it's a resin that solidifies. It's also an industrial technique, also done by JLC. And this is important. This is a new thing that I wanted to try. I never did before. The ears, the horns, and the inner mask, you know, that was touching my face, they need to be flexible, kind of flexible. So I sent them to manufacture in SLS TPU, in TPU, which is the usual TPU material that everyone uses. But this is SLS, so it's also laser sintered. The only one who offers these things, as far as I know right now, in China at least, it's PCBWay, if you guys want to know. I don't know if I would do this again. It's a bit on the expensive side, but it's an option. So a week later, well, 2 weeks later, receive the package, all the parts, at least the solid parts, the rigid part, the TPU parts took more time. So let's see. These are the structural parts, you know, that I received from JLC. They're amazing. They look amazing. They're absolutely high quality, super high quality. I also modified the box cut files to integrate a lot of brass threaded inserts. These are cheap as hell, and you can totally buy them anywhere. And this is way more professional, way more rigid than just self-tapping in plastic. And you can do this in any plastic part, in any thermoplastic part. They melt in place with a soldering iron. This is how it assembles. It assembles really well, extremely well. And you end up with a structure that's beautiful, absolutely beautiful. It looks like sandblasted. The SLS looks like sandblasted nylon. It's very pretty. So there we go. Structure. And these are the transparent parts. As you can see, I also printed two visors, because at that point I was thinking, maybe I can 3D print the visors. Bad idea. I'm going to talk about the visor later. Let's focus right now on the parts on the low part of the screen. These are the light pipes. Okay. light pad for the side ears. And let's go to the fur now, which, I mean, it's called a fursuit, right? Should have some fur. So I bought a lot of fur locally. Apparently, you can buy a lot of very cheap. Fur is extremely cheap. I totally extremely overpurchased. Like, I thought I was gonna use. I bought like 10 times the amount of fur I needed. I really had no idea how much I was gonna need. But well, now I have extra to make like a full body suit, I guess. I just bought it locally. They're used for making like nice pillows or whatever. And I bought a sewing machine because it was $50, and you know it will really help you to make stuff quickly. I've never used a sewing machine ever, honestly. After making this, I realized, okay, this is very useful and a very useful skill to have in your life to actually know how to sew. Maybe you can fix some clothing, you can edit some, like modify some clothing for yourself. You learn how to use a sewing machine. It's a good skill to have. Okay, how do you put the fur? I basically did the traditional method for doing this, which is making like a duct tape dummy on top of the parts you want to cover with fur. And then, which is essentially, okay, you cover it with like plastic foil, the kitchen type, and then you cover it with duct tape. And then you basically just cut it out and unwrap it the best you can. If it has too much curvature, you just cut it there in the curvature and you expand it. This is very manual, very eyeballed it. Pretzel over there made a way better technique using computer-aided unfolding and wrapping. There are better way of doing this. But this is simple. This is simple, and you don't really need too much skill other than just doing it. And I cut the fur there. I left like a centimeter extra for sewing, and this is literally the first time I sew anything. So pardon my sewing skills; they're terrible. But the good thing with fur, mostly long fur, is like it will just hide any defect. This is plus or minus 1-2 centimeters. No one cares. It's impressive how tolerant this is to mistakes. So this is how it looks when you put it back. I made a very pretty wig here. Yeah, nice wig, bro. And this is after I trimmed it a bit. You know, I grabbed literally my beard shaver. I'm not joking. I grabbed my usual shaver, and I just shaved the head. I shaved the head the best I could. I would recommend to get a proper head trimmer, like for industrial use, something that's heavier, maybe something for like veterinarian use. I don't know, something bigger, because the smaller ones that are just for beard, they're too weak for this application. And okay, you trim it like that. Let's go to electronics. Received 2 more boxes from JLC and stuff. The boards are already here, assembled and everything. The minimum the JLC is going to do is 2 boards. So you're going to have 2 sets, basically. We're talking about 2 boards assembled, okay, with the components. So you're going to have 2 sets. If you want to make 1 set, you cannot. You need 2 minimum. It's still relatively affordable, okay? So it's not really a problem. The other panel set I purchased, I sold to a friend of mine who totally got kind of inspired by my build and wanted to build something else, so I sold the second panel to them. All the panelization you see here has been done by JLC themselves. You don't have to do anything. Okay, I mounted the electronics I built. Why is it passing along? I want that. I mounted everything in the frame. I built the board adapter, okay, and then basically we can power it.
Oh my god, this is cool. This is really cool. And it has the boop sensor.
Is it playing with sound for you guys? It's working well?
Oh, wow. You hear it, yeah.
And it has sims that I haven't finished yet. I have to calibrate the microphone. But you see I'm talking and the thing is moving a bit, I think.
Beautiful.
And then it has a couple of
Oh my god.
other modes, like this one. Sound reactive.
Wow.
This is default Proto Tracer firmware. I literally downloaded from a GitHub, loaded it into the Teensy, and it just works like that. I'm avoiding 4 hours of debugging where it wasn't working at all and it was just connecting the panels in the wrong output. Okay.
Like this is another spectrum analyzer.
It's another mode.
I need to configure it properly, but it's like you hook it, and it's like the face appears. No, it's really cool. It's really cool. Of course, it's mirror, right?
As I said, this is default. You can edit the code is very well commented. Okay, so side panels. Side panels. This is the ears with the light pipes installed and my custom boards behind them. You know, they have the same kind of RGB LEDs that I put in the panel, so you can individually address every single LED. I did not do that yet because that requires a lot of firmware tweaking, and I didn't have the time. I haven't had the time to do this. But well, it's doable. So TPU parts, more boxes. Okay, boxes, PCB way. Here, there we go. Yes, I was literally unboxing this in my car because it was too cool to not unbox in my car. So I pulled down the ears there. They look really cool. These are literally 1-to-1 scale Nardo ears. It's kind of crazy to hold them in your hands, you know.
Yeah.
So these are the TPU parts.
So
Okay.
here,
Awesome.
this is the stiffness you get
you know,
with TPU.
kind of soft. They're not gonna. It's not gonna flop in this direction. It's kind of rigid. It's not that rigid.
Whoa.
These are
I made the
horns.
horns flexible as well to not kill anyone. Okay, if I
Flexible,
just
no,
was
but I'm
just
not
hitting
gonna
them with the
put
horns. You can also 3D print them in
not-
something else, something more rigid,
drop
maybe even
the-
titanium.
It's the mask.
Titanium
Titanium.
mask.
Fine. Really good. I like it.
All right. So this is the final look with the ears put together. And okay, let's see. We are gonna cover them in fur because of course we'll do the same thing we did before. We cover them with duct tape. We cut them around, and we cut them in different parts. We sew everything together, and we end up with, well, fur ears basically. I sew them at the base of the TPU thing because it's CPU. You can sew through it. Okay, you can just get a needle through it. This was like manual sewing, and that's how the fur is held to the base. And then, okay, you put the ears into the structure, and there we go. Okay, this looks exactly how it's supposed to. Let's see, the horns and the ear tips. Okay, gold, literally. I literally purchased like a spray paint, gold spray paint, that just spray painted the crap out of them. Maybe it could be done better. Honestly, I would love to have someone actually making some artistic painting on top of this thing. That's an interesting look that you could do. I didn't have any time, remember, I was doing this 2 weeks before Eurofluence. So, yes, gold, okay. This looks more or less all right. Looks very close. No, not that much. We're missing one thing, the visor. And something else. Okay, the helmet pads, I forgot about this. Helmet pads, this is the inner thing. A lot of people just start improvising this, start getting foam inside the head, trying to fit them to your head. That's a lot of waste of time to buy helmet pads. You can buy commercial helmet pads for like military use, and just buy them. They come with Velcro. Just put the Velcro inside and just accommodate them inside the head for your head fitting, and it's very cheap. It's easy. It's super comfortable, and you can tweak them as much as you want. Now, visor. Yes, a freaking visor. Okay, how do we make a visor? First idea I had. Okay, we are sending everything to JLC. They offer like a fully transparent option. Is this gonna work? Let's see.
Okay, so this is the visor, 3D printed, resin 3D printing, transparent and polished. So this is the thing, it's not fully transparent. I mean, it's mostly transparent, but it has some artifacts, right? So this comes from the...
So basically the surface is a bit too rough. So no,
my
I would say
impression.
no, you cannot use this. I tried to polish it, because of course I tried to polish it. I wanted to save it because I really didn't want to make a thermoformer, and I had a week.
Okay, this is as transparent as I made it, which is polished.
This is polished.
Polishing it.
You got
It's
better.
not terrible. It's not perfect. It's not terrible. You can actually use this, kind of. This is a 3D printed part. This is a 3mm 3D printed part.
It's not great. It's not terrible. I don't like it enough to actually recommend it. Don't do this. I was just a bit stuck because I had like a week, and then I tried to tint it, and I actually tinted properly. You know, I tinted it with like regular polyester dye and at high temperature. But this took quite a long time, like an hour, and it's not that dark, and it doesn't look great. It's not great. It's not good. It's not properly transparent, and you know, it's kind of like the printing layers is doing kind of an interference effect that just doesn't look very good. Okay, don't do this. And it also, if it falls to the floor, it's gonna break, which luckily it happened in my house before I went to Eurofriends, because that forced me to make a thermoformer. And I decided to make a thermoformer 1 week before Eurofriends. Okay, so I grabbed a bunch of plywood boards. Okay, I started cutting them. I put some silicone sealant on top of them, completely improvised them. I had no time to make them pretty. I totally programmed my CNC to make holes.
Well, I guess this will take a while. Those are a lot of holes, okay? Yeah.
All the holes. So anyways, we have all the holes here, and then we glue everything together, and then we have a very stupid thermoformer that you connect to your vacuum cleaner, and that's it. Okay, because I was having a hunch that the 3D visor, printed visor wasn't gonna work great. At the beginning of the build, also ordered that mold. That mold is also made in SLA, is printed in SLA, so it's printed in resin, so it's very, very, very smooth. You can also 3D print it with regular 3D printer, but you have to sand it a lot. Okay, so that's how it fits in a thermoformer. And you know, this was the first attempt, and it kind of worked. But this is with very thin PETG that I found, which is about 0.25 millimeters. This was basically unusable. It was very, very thin. So my next attempt, okay, I purchased 1 millimeter PET, not PETG, because it's the only thing I could find in my country. No one was selling PETG sheets back then, 1 year ago. Now I can find them, but 1 year ago, no. The problem is the PET has a glass transition temperature at 120 degrees Celsius. If you go over 120 degrees Celsius, the plastic is going to become extremely stiff, white, so it's going to stop being transparent, and it's not going to thermoform at all. So you have to keep it under 120 Celsius. That makes it that you have very little room for working with it, because okay, you put it in the oven. I was also using like my kitchen oven, okay, putting the sheet in the frame, putting the frame in the oven. The frame I made exactly the same size as my oven, by the way, and then you heat it up with the oven until you get to the right temperature, and you pull it out, and then you put it in the thermoformer and pull the air. But you have to be very fast with PET, because you can go up to 120 Celsius, and the thing gets very rigid under 80, 70 Celsius. So you have very little margin there. With PETG, what people do is, okay, they're heating it up up to like 170, 180. PETG is going to work great, doesn't matter. PET is way more difficult, but it worked. This was my third or fourth attempt, but it worked.
Okay, these are like the 1 millimeter PET thermoform. These are really good. You can really use these ones. This is thick enough. Like 1 millimeter, I think, is about the thinner you want to go.
And then the problem with dyeing it, I like dyeing PET. It's usually done with polyester dyes. For some reason, I just decided to use a local polyester dye, like a locally commercially available that's manufactured in Argentina. It's whatever I had available. At that point, I could not buy a dye in Amazon, which is the typical dye that people use. I couldn't buy it because I didn't have any time. It was going to arrive after I left for Europe, so I needed to make that work. The problem with the local dye, it was extremely difficult to dissolve. And it was just leaving a lot of residue, and that residue was captured by the plastic when you put it in the bath. And to make it more soluble, you have to increase the temperature, which also makes the dyeing faster. But the problem is that the plastic gets affected by the temperature for long periods of time. So you have to work at lower temperatures, make extremely sure that you were removing all the residues from the bath, and tint it for long periods of time, 5 hours maybe. This is because of the dye I used. The usual dye that you buy in Amazon works much better. Don't try to do what I did. Don't use the Argentinian dye. Okay, this is working apparently. So yes, I had to buy the proper tinting, which is explicitly for polyester, and you have to skim the surface to remove the undissolved residue. You still have some residue at the bottom. See? So, but this is coloring. I mean, this is clearly tinted. This is working. Oh my god, I'm excited. Getting to this point took a week of failures, by the way. That's something that you don't see in the video. But it took a lot of failures, a lot of failed attempts. Also, like I tried a different variant of that dye that was not exactly for polyester, but for other synthetic fabrics, and it didn't work at all. You need specifically the one for polyester. Also, you go to high temperature, you're going to destroy the visors. That's how it looks when you destroy the visor because of high temperature, okay? Just to be clear, that's how it looks when you don't do it right. Because that's important. People show you the right way of doing it, no one shows you the failures. This is the failures of high temperature. And this is when it works great, okay? When it works nice, it comes out like this. Okay, this looks like a visor now. Okay, that's great. Okay, now it's working. Okay, it seems that we managed to do it. Okay, that's great. We put it together. Yeah, it assembled. Holy shit. Okay, this looks like a Protogen now. You know, it's impressive how the looks change when you put the visor in there, and suddenly it looks like, instead of a pile of parts, it looks like a Protogen. It's great. The visor is there and nice, it's lovely.
I use double-sided tape. This one.
I wanted to show you guys also the transparency this has.
Let me take this out. To set the visor to the plastic part. When it has a magnet, and I put some.
It has a bit of distortion, but not that much. It's very little. It's very reasonable. It is very useful.
That's all over. And this is very resistant. I think. I hope. This is fine. This is very usable. And the visibility of this is. I want to say it's a motorcycle helmet, but it's very fucking close. And it doesn't introduce a lot of distortion. It's really good. This is the visibility. Okay. So what did I do? I went to Tokyo. Why? Because I felt it was cool to do. Okay, there was no reason for doing this. I have a lot of anecdotes. I have a lot of anecdotes about doing this. The first one is that, as you can see, I was using a white cable. That white cable is a micro USB cable. I'm going to talk about the technical part first. That's because I was literally powering the head through the Teensy. Because my USB-C connector from the board, I ripped it. I completely ripped it in the hotel. I was trying to connect the USB-C connector into the board to power the head, and I destroyed the connector.
in my hotel in Tokyo. So thank God I left the micro USB connector on the TNC, which is usually used for programming. I left it exposed so I could connect a micro USB and power it from there, or I would have literally destroyed the thing. So yeah, I did all of these things just using this goofy replacement power routing. The other thing is some very fun stuff. Like my brother was spotting me. That means he was actually helping me navigate the streets of Tokyo while I was wearing that thing, because the visibility is not great, mostly at night. And at some point, some old Japanese businessmen approached my brother. I don't know. I think he wanted to hire sexual services from me. Let's put it like this. While wearing the Protogen head. That was crazy. That was one of the weirdest experiences I ever had. He was speaking in Japanese in some like old school dialect of Japanese. He was talking with my brother. My brother speaks Japanese quite well, and that's what he told me, and he was really laughing about it. Yeah, that was the other anecdote I had. I had a lot of people wanting to take pictures with me, and it was really fun, actually. This is another video.
I lost Apotek in Capucho. Apotek 迷子になりそう多分
Yeah, no, that was really fun. Something I learned after the accident with the connector, okay, I want some internal power supply on this thing. So I decided to integrate a battery into it. This is literally the first attempt I did. Basically, I disassembled a 5,000 milliamp hour power bank, and basically I fully integrated into the right ear. Behind the LED panels for the lights, basically, for the light pipes, I basically integrated the battery. I integrated the LED battery gauge on the right. You can see there, and under that there is an on-off switch by stable button. And basically this becomes basically a power bank. This is literally a power bank just integrated into the thing. It looks like this. Right now I'm modifying this. I'm gonna add a second battery. I'm trying to design some kind of battery management system for Protogens, because I've seen a lot of weird, poorly improvised things from other makers, and I don't like it. So I'm going to try to make some kind of BMS from Protogens, battery management systems, and I'm going to, of course, open source it if I have some time. But yeah, this charges via USB-C, or you can use the USB-C to charge it and power the head at the same time if you need more battery. Yeah, this is the result of having a battery inside, right? No cables. And that was really useful for doing something else I did past like a couple of weeks ago, which is literally getting into a hot tub with the Protogen. Was really fun. So yeah, there we go. That's the presentation. So any questions?
If you have any questions, we'll be passing the microphone around. If you are on the YouTube, please put your question into chat, and we'll have a staff member relay the question for you.
Hi, Clarkson. There's a microphone. Oh, there you are.
Oop, did you make it to Eurofurence, or did you go to Tokyo first?
Yes. No, I went to Eurofurence first. I made it to Eurofurence. I unfortunately didn't put the video here, but yeah, I was in Eurofurence with the Protogen. It was really fun. Actually, I'm in the community show of video from Placeholder Cloud that was running Eurofurence along with the creature Foxin. I'm in that video with him. So yeah, it was a Eurofurence. I was at Eurofurence. Yes.
Fun times. If that power bank, is it a lithium one in your ear?
Lithium
if it pops, would it fry you?
It should not. But yes. Let's pretend it's not gonna happen.
Okay, I'm just looking at this picture of you in a hot tub with a bunch of lithium strapped to your head, and I was like, yeah,
Of course.
it'll be fine.
And I'm gonna put the other battery in the other side, you know? Just,
Bounce out the blast.
yeah. No, it's fine, it's fine. It has a couple, it has the battery protection, it's well made. I
Hey,
think.
did you know that if you leave your car in your garage running, you will die of carbon monoxide poisoning?
Wow.
Protogens don't have to breathe.
Exactly.
Yeah.
I have so many questions, but the one I am going to ask is how many amps is your entire head drawing, and how long does it last generally on a 5,000 milliamp hour battery? I guess, and could you explain a little more about the power system in general too? That'd be great.
Yes. The power, the thing consumes 7.5 watts, so 5 volts, 1.5 amps. That's the average current consumption of the whole thing while it's being in use. It might have some peaks if you boop it, but honestly, it doesn't have any bigger low. It doesn't fluctuate that much. It's honestly around 1.5 amps.
So 3 hours by my napkin math.
Yeah. Okay, it's very very close. 5,000 milliamp hours. The efficiency of the DC to DC converter to go to 5 volts. The whole power power bus on the head is 5 volts. The LEDs are powered by they are like the typical smart LEDs, you know, you daisy chain. They're powered by 5 volts. The microcontroller has its own linear regulator to lower it, I think, to 1.8 volts. I think it was it. But that's very, very low power consumption. It doesn't matter. The battery, of course, needs to be boosted to 5 volts to have this. There is the battery charger, which is an ETA 90 something, 92. I don't remember the code exactly from ETA, from the manufacturer's ETA. The battery charger. It can also reverse boost the battery to 5 volts. So a single IC converts from the power charging on 5 volts to charge the battery, and then going from the battery voltage to 5 volts. The efficiency of that is about 90%. The battery, which is right now 5,000 milliamp hours, lasts between 2.5 and 3 hours. But because of the topology, you can the USB-C that's on the side, you can connect it to an external power bank, and the power bank can charge the battery while powering the head, so you haven't extended. I'm trying to extend the batteries to 10,000 milliamp hours because the time is a bit low in 2.5 hours.
How do you attribute that to only the 7 watts out of the LEDs? Are you just not running them at full brightness, or is that just how efficient they are?
Both. The WS35 LEDs, they are super mega efficient, and also they are not running that bright. Like I'm running them around, I would say, 10 to 15% the maximum brightness.
Yep.
If you're running it like at 100%, you are gonna run 100 watts, you know. But you don't want to do that. Also, why would you do that? You're literally gonna scorch the earth. They are extremely bright. Holy shit. You don't need.
Awesome, thank you. I'm gonna hit you up for. I'll hit you up for designs later, but that's a different section.
Yes, of course. You would honestly, it would be nice to have the option to have more power on the LEDs if you want to go outside during the day. This looks great at night. It looks great in parties. Looks great inside a building. It's sunny. If it's sunny outside and you just go outside, the LEDs are too dim. At 10%, you would like to go to 40%, but 40% is gonna be like, okay, you need to manage like 30 watts of power consumption. I did not do that. Any other question?
Hey, Apotek, great lecture.
Hi.
Just a question. What do you plan to do? What helmet do you want to do next?
A different project? Completely different project?
Yeah.
You mean?
Yep. What's the next project?
If
Oh my god.
I would have the time to do it, which is a very big if. I want to do this. I want to do this. The problem is the technology for making this and making it look how I want it to look. I would like to add some animatronics, to be honest. It's a mess. It's very complicated. It's a lot of time and effort. Would love to add some servo motors to move the mouth and the eyes. It's gonna. I don't know. I just have a feeling that if I start building this, it's gonna be uncanny, and I need to put a lot of resources into it. To make it look proper. Also, if I could do this, maybe this, but with some like electronic display, like which is curved on the eye part, you know. So making some animated eyes into a Rexo head would be great. You know, all of this area, not only the eyes, but all of this area. You know, make it like a Protogen display all around the eyes, and maybe some LEDs behind the fur. I don't know. It's a crazy idea I would like to try. Probably gonna look like crap. Probably not. I don't know. It's something that hasn't been tried before. Well, actually, there are a couple of. I think Forbidden Studios did something kind of like that, and it was looking really cool.
Oh, yes, with the OLED.
Yeah, and also Wick has made some custom shape stuff. But yeah, more custom stuff. Definitely would love to try something. Also, I want to approach more of a Fox kind of look.
Gotcha. Thank you.
Okay, I've got two what will hopefully be quick questions. One, can you tell us about the boop sensor? Like, what is that?
Oh, yeah.
Is it just an IR? Is it just like a near IR sensor that's just detecting
yes.
like a solid object?
It's a specific. It's a pre-made board that you buy from Adafruit, based in APDS 9960, if I'm not mistaken. That's the code. It was pre-coded into Prototracer as well, you know, as an external module, so you don't have to add anything other than just load the uncomment, you know, the code. Basically, you buy the module in Adafruit. That component is a very tiny component in that board, in that sensor board. Yeah, it's infrared reflection sensor, basically.
Gotcha. Okay.
It has an infrared LED and a photodiode. Actually, it's actually more than that. It's 5 of them. In different directions, so you can do gestures, you know, in different directions, and it detects the direction. That's something I did not implement, but that IC can do it, and it's gonna do all the processing for you. You don't need to do anything; it's just gonna tell you the direction. Basically, the Prototracer software will subtract the background. So basically, you put the visor, it's gonna calibrate to the average brightness level, and when it sees a dip on it, it's gonna activate. So yeah, it's brightness and emission.
Okay, so that integration is basically like part of the basic kit that you bought, essentially. Okay.
Yeah, I didn't buy it. It was just free. I mean, I implemented it.
Okay.
Yeah, the code was free.
Could you tell us how you were doing temperature regulation in the oven, and then for the dyeing thing? I don't know whether you did that the same way for both or not. Just curious.
A thermocouple. Just like a multimeter with a thermocouple.
Okay.
And just put it.
And then how did you have one? Did you have one, and how expensive are those? Are the ones that you used?
Yes, I have a multimeter with a thermocouple. Yes, I had one. It's really cheap. Just buy a multimeter with a thermocouple. We're talking about a cheap one, $25-$30 maximum.
And you put that? Well, you put that in the oven?
Yes. No, I mean like the multimeter is outside, you know, and there is a thermocouple wire going into the oven.
Okay. And then the same for can you get them wet?
Yes.
Okay.
I wonder if you could sous vide a visor.
I was thinking pressure cooker.
I guess a fun prospective question now that you know how to do these techniques. I've seen ways that you can like inject fluorescent or
otherwise like quantum dots into polymers.
Let's go.
Would you think that it would be fun to experiment with, like having that so that it like follows the shape of the protogen head?
Where do you want to inject them? Into the plastic?
Yeah, into the visor.
If you manage to make a hot roll system to actually make the plastic and then make the sheet, before thermoforming, maybe it would be fun. I mean, they would fluoresce, right? With the light from behind.
Yeah.
I mean, sounds fun. Do it.
My smart TV on my face.
Yeah, I mean, you're not gonna make a display out of those quantum dots. I mean, but you can like trigger the fluorescence. It would be interesting.
That's true. You would need like a stack to make it.
Presel had this idea. Yeah, you need to add all the electrodes and everything to apply some kind of electric field to actually make them into a display. Like an idea we had with Presel. Well, actually, Presel had the push for doing that, the energy to do that. He wanted to make a curved display, which would actually follow the curvature of the thing, right? Instead of having flat displays. Basically making a flex PCB, that would origami in the inside of the thing.
Mm-hmm.
It is doable. It's just gonna cost you $2,000 to make. No, I mean, if you wanna spend it, how much was it? Where is Pretzel? Was here? Oh, there. Yeah. How much was it?
I think it was about $2,000 to order the PCBs built, or alternatively about $2,000 to buy the pick and place machine to make them yourself.
Yeah, so
same amount either way.
A flex PCB with all the LEDs on flex PCB, but it's quite crazy, but it's something that's doable. Will also obstruct your visibility like a lot. You need to be careful with that. You need to see. It's funny how no one thinks that you need to see through this. It's important part. Like another idea was to integrate a VR headset inside, which is doable.
Seen it done.
It's doable. It's difficult, but it's doable. It's expensive as well.
That's terrific.
Yeah, a camera with a VR headset.
Curler works on that one right now.
Yeah.
Yes. I did a bit of research into that area. I was doing some custom driver for the big screen beyond. I never went through it too much. I did a custom HDMI display port board for the big screen beyond, way more compact than the usually like breakout box they provide, so you can integrate into a first head, all integrate into the head, but I didn't go through it. Like my first prototype was a failure. I needed to iterate a lot and have more careful with the DisplayPort signal integrity and shit. I didn't go through it. I didn't have the time to do it. It's something to explore maybe, if someone wants to. More questions?
Question. Did you put like big lenses in there that would also bend the light into the visor shape? Or is that like crazy?
What?
Could you use like lenses to distort the lights from the flat LEDs to make them look more like the visor?
That's a custom lens with a custom curvature. It's a free-forming lens. It's gonna cost you more than making the display we described.
Oh damn!
You would need to have your own UPM.
Yeah.
Damn, I thought that'd be like the easy solution.
$500,000 on your bank account for that.
Yeah.
Yeah. Wow. At some point, when I was failing at tinting the visor, I was thinking about throwing the visor into a spotter coater. Just coat it with some metallic layer, maybe chromium. Like 50 nanometers of chromium on top of the visor. I was 50 minutes from doing that because I could just go to
to my lab and just ask for some time there. But I had like 3 days before Euroference. That was an option. I was a bit desperate. In the end, the tinting worked, but it was tight. You also need to be careful with the spatter coater to not overheat the plastic, right?
Details.
Yeah. Any more questions?
I've got another one. I was thinking, like, when you reach the point that you said that you're just doing it like in an open pot, like on the stovetop. I was wondering if you had like a sacrificial like pressure cooker, would that have made the process easier? And I mean, like, you would never make food in it. You would probably never want to make food in it again, given the, you know.
It was a sacrificial pot. You're talking if
Right,
it would
yes.
have worked better in high pressure, in a pressure cooker. I would say no. Well, actually, I don't know. I actually am not sure. Maybe pressure alters how fast it dies. Usually, pressure cookers are used to heat up liquid over the boiling point at room temperature. And to be honest, I had the opposite problem. Like, I had to tint at very low temperature to not alter the plastic. So making it so it can get hotter, it wouldn't be a good idea at all. It just doesn't serve the purpose. I don't know if increasing the pressure, but the problem is pressure cookers increase the pressure by actually boiling, well, trying to boil the thing and not being able to. So no, I'm going to guess it's not going to work good.
Could you do it in like a sous vide? Could you do it in like a sous vide machine?
Why?
No, that probably is the best way to go, honestly.
Just constant water temperature.
I just put it in an electric stove that was also sacrificial and completely destroyed. I just have to heat the pot to 45 degrees Celsius, more or less. I have to do it very, very cold. Like, that temperature is very cold compared. Yeah.
Were you playing with the temperature, or could you just set the flame or set the dial?
Yes, just you have to imagine that 20 liters of water has a lot of thermal inertia, a lot of thermal mass. So basically, I was just heating it to 45 to 50 Celsius, and I was just doing on-off control, manual on-off control. You know, the thing with my thermocouple, and just every 10 minutes I was just checking the temperature. It was not that problematic to control the temperature. It's a lot of
manually.
Water.
Okay.
Yes. You just have to be careful with hot spots at the bottom if you're going to heat it with an open flame. This was not an open flame. It was an electric heater at the bottom, like an electric stove.
Yeah. Almost too high.
Yeah, what would you say your yield was, given you were doing your own visor work? Because I remember when I was trying to do it, I maybe got one every like 10 or so. What would you say for yours?
Just from the yield of the whole process, from buying the plastic thing to actually having a good visor, the good shield. Now that I have refined the recipe, I would say the yield is over 75%. I would say no, it's good. I think it's good now. Like, just consider that I don't do this industrial. I just did it for mine. Okay. But after the process was fine, it's fine. What I see is because I use PET, it was sometimes I was failing in thermoforming because it was too cold. It was too slow to pull it. Okay, that's a point of failure. And another point of failure was the liquid for dyeing needs to be clear enough. You know, you don't have to have any debris or residues inside the pot. When you are in that point, you just put it there and just wait. You have to wait a lot, like 5 hours at 45, 50 Celsius.
And then with the 3D printed visors, would you say the problem was more the internal layer lines, or was it just that you couldn't get a good polish? It was the internal ones, okay.
Both.
Because I was wondering if you couldn't just keep polishing it with like a...
No, it was the internal... Actually, it was the changes in index of refraction between the different parts of the acetyl layer that was basically causing some kind of refraction in the light. was generating like a lot of interference patterns, and that was after I finished polishing. At the beginning, before polishing, okay, it's the surface roughness that's a bit rough, okay, because it's not just the plastic. They actually applied like a transparent coating on it to cover imperfections, and that's great, but it's not smooth enough. You have to polish it. I polish it first with sandpaper and up to like 5,000 grit. And then you go with polishing pastes, with 3 or 4 polishing pastes. You know, I spend like 5 hours with polishing pastes. Okay, you get to a point where it's actually very smooth. But it doesn't behave the same as it was a solid object, like a full solid piece of plastic. Different parts of the layer has like different refraction, index of refraction. That's my interpretation of what was happening. So yeah, it's not good.
Ooh. Wait, where'd the microphone go? Oh, it's over there. I have a very important question.
Yes.
What happened? I've worn lab goggles before, and I'm very interested to see what happens to your visor when you start sweating. Does it fog up?
No, because of the design of this particular Protogen. That's why it chose the box. It has an inner mask. It totally pulls the breathing down. Actually, let me find my controller. There we go. I'm gonna show you. It has a fan inside. It has a Noctua fan, 40 millimeters, that basically just get into your eyes, to be honest. But let me show you the design. Back.
Oh, I'm curious about that because
See here.
I have a lot of problem with that.
Yeah.
With mine.
See the inner mask? Okay. Don't think about where the nose is here, because that's not where the nose is. It's just that's the mannequin I got. But that's where the eyes go. You know, so your nose is down, and you know you just breathe down.
Yeah.
Basically, let me show you another picture. Let me show you the render. Actually, that's better.
Oh, is that
Where's the render? Here, check the render. See, my nose just exhales down.
There. Yep.
It doesn't exhale into the visor area.
No.
Okay.
Yeah, that's good.
I was
And, like, if
wondering
you
why
have,
the inner
like,
mask had a muzzle on it.
Also, if you have like
yeah.
sort of like
I
issues with
saw
like
it.
That was just for
films or
fun.
like other
Yeah.
surfaces in
It's
front of your face,
fantastic.
you can like
It's
coat
like a
it
mask.
in just like a little bit of toothpaste or stuff like that to break the surface tension, and that'll prevent condensation from building up. Yeah.
Oh, cool.
Yeah, you can do, as long as you have a fan blowing across your visor, it acts like a defroster
Yes.
in the car. So yeah.
Yes, it also has a fan, by the way. I didn't talk about the fan, but there is a fan, and you can see it in this render on the left. It's just horizontal, and it's just pulling air towards the eyes and stuff. That fan is very important. You're gonna overheat like crazy if you don't put a fan.
Yeah.
Yeah, one more stupid question. So when you're forming the visor, how do you introduce heat into that? Like, you have the vacuum to pull the plastic.
Yes.
How did you introduce heat there?
No, basically, the plastic is held into a frame, a wooden frame.
Yeah.
That's the size of my oven. That thing goes into the oven, and it heats to 120 degrees Celsius.
Yeah.
Then, the moment you pull it out, you are not introducing any more heat. That's why you have to be very fast. And just
Gotcha. Okay.
push it very. Yeah, just use the thermal inertia of the plastic. That's actually a big problem of this. Like big industrial thermoforming system have a couple of infrared lamps on the top that will keep heating the thing while it's thermoforming. Just not mine, because I made it in 3 days.
Right. Yeah. YouTube comments. Do we have any?
Oh no.
We do have one.
Questions. Yeah. Great.
But are there more questions? Usually we do that at the end.
I'm good.
Oh, let's hear the YouTube question.
The YouTube question is half a comment, half a question, so I'm going to interpret it. The comment was they saw another person posting on YouTube dipping Protogen head in order to dye it, and they were wondering if you were the one to post it to YouTube, or if you basically the question is, did you post your dyeing video to anything else?
No.
It's a strange.
No, it was not.
Question.
It was not me. No, it was someone else.
Okay. It's a strange question
also,
in the sense of
also,
asking
yeah,
if
you have
were
to
dying,
dip the
dying
Protogen
video.
head into the water, well, into the dye. But the thing is that takes way longer than. It takes longer. That video is edited. Like, you need to heat up the dye with the water with the dye, you know, and you put the visor inside the thing. And like, if everything is perfect, you know, and the dye is completely dissolved into the water, you need to put it there at the right temperature, and you just have to wait. I guess the Amazon dye, the dye that everyone uses, it does it quite quickly, apparently in like 30 minutes, I don't know. Mine took like 4 hours or 5 hours, and it was really problematic to use. Don't use the same I used.
So I got a question, like, so why do you have to dye it afterwards? Like, so why do you have to dye afterwards? Like, all of the dyes have issues with like the thermoforming process or something? Like, like is familiar with that, or why not just have a sheet in the first place?
Never try that. I just don't know. I don't think that would be easier to dye before. You would have to dye a very big.
Well, I'm just thinking if you already have like a piece of plastic that's already tinted, like, in the right color. Or,
I couldn't find a plastic that's already tinted in the right color and the right thickness. I couldn't find it. I also I found a very thin one that was already dyed. But also the thing is, like, this stretches a lot when it thermoforms, and the color gets completely diluted by the stretching. That's also true. That's also true.
Okay, yeah,
and it's not homogeneously.
Okay.
Also not homogeneously. You know.
That makes sense.
Some parts stretches more than others, so it's just no.
Okay. Yeah, that makes sense. Well, be as even. All right.
Yeah.
It's also really hard to judge how dark it's going to be in the final product until it's in that shape, too.
Yeah. Hopeless. Yeah, true.
Any more questions?
No questions.
Okay. Well, thank you very much, Apotek. You have any closing words, or?
No, that's okay. Yeah.
All right.
That's it.
All right. Thank you very much, Apotek. This was a lecture on Apotek building, designing, and wearing his Protogen head. He's an electrical engineer and physicist, so he has a pretty solid foundation for doing this. Now, for anybody who joined the stream midway through or joined the lecture midway through, this is DegenTech. This is the formal monthly lecture that we have. It's part of our social meetup schedule. And this is our monthly lecture where we grab one member of the community and they talk about their specialization or topic of interest. And DegenTech is a group of techie furs in the professional techie furs in the STEM field, STEM being science, technology, engineering, mathematics, and medical. So we're a bunch of techie furs on VR, and we like to hang out. We also have a Discord. Come check it out. Thank you very much for checking out this lecture. Also, I forgot, I had one more announcement, and I didn't mean to do this on stream, but honestly, it's auspicious that it's on stream as well. So if anybody wants to be going to a convention and running panels for DegenTech, please contact me or contact anybody on the staff. We have plenty of resources to help facilitate live meetups now, and we would love to have more of a real life footprint in the real world. So if you guys go to any conventions, we already had a couple of people run a couple of panels at conventions already for DegenTech. So if you happen to go to a con and want to run one for us, we would love to help out. All right. Thank you very much, everybody. This is the conclusion of the formal portion of the meetup. We're going to be around to hang out, but the stream's going to end. Thank you very much for watching. Thank you very much for hanging out. And yeah, we'll probably go to a cool down world in, I don't know, 5-10 minutes here. Thanks, y'all. Hope to see you at the next one.
Thanks, BTEX.
Yay!